Right. Yes. So in your last class in photochemistry, we discussed about what is NARIS2 and complete applications on NARIS2. Okay. So that is about photochemistry of carbonyl compound. So after that, now we are going to discuss photochemistry of alpha comma beta unsaturated carbonyl. This is photochemistry of alpha comma beta unsaturated carbonyl compound. So this is a concept where you can expect a specific reactions, especially for rings. It is applicable for rings, not for open chain. Photochemistry of unsaturated carbonyl compounds. Now, which means, see, here these photochemical reactions are not applicable for open chain. For open chain, these photochemical reactions are not applicable. It is always applicable for a rings. Alpha comma beta unsaturated rings, these photochemical reactions are possible. Only rings it is possible. Only for rings, alpha comma beta should be present in ring and carbonyl is also present within the ring carbon. But what about here? Both are open chain. So this concept related to cyclic conjugated carbonyl, but not for open chain. Okay, open chain never undergo photochemical acceleration. So because here there is a single bond character to double bond character possible. So if I say alpha comma beta unsaturated, you follow only rings. Don't go for open chain. If I use the word unsaturated carbonyl. Okay, right. Write down. They involve following photochemical reactions. Following photochemical reactions. So here it is photocyclodimerization. Photocyclodimerization possible. Then photocycloaddition. Then cis-trans isomerism. Cis-trans isomerization. We can convert cis and trans isomers by using photochemically. Then finally, pi bond migration. Pi bond is going to be migrated. So these are the variable reactions of unsaturated carbonyl. Photocyclodimerization, photocycloaddition, cis-trans isomerism, one more is pi bond migration. So this pi bond migration is applicable even for open chain. But remaining maximum cases, these three is the key reactions only for cyclic rings. Only for cyclic rings it is applicable, and this is even applicable for open chain. Okay. Now first one, photocyclodimerization. 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 Here we can write dimer product. See, dimerization of cyclic alpha comma beta unsaturated carbonyl compound. Unsaturated carbonyl compound to give dimerization of cyclic alpha comma beta unsaturated carbonyl compound to give cyclobutane derivative. Mostly you will expect a cyclobutane derivative here in light. So we are using a light radiations and we are applying this in presence of light. Getting a dimerization product, and here this dimerization is possible with a cyclic unsaturated carbonyl compound, and that will give a cyclobutane derivative in presence of light. Okay, so here see the characteristics of this reaction. So first we need to irradiate with suitable lambda. suitable lambda of carbonyl compound. Here alpha comma beta unsaturated carbonyl compound is required. Okay. So next one. Here see, reaction excited state is pi 2 pi star. Here it is pi 2 pi star. It is not n2 pi star, pi 2 pi star triplet. It is a different one. This point is most important. Reaction excited state for dimerization is pi 2 pi star triplet. Okay, and especially this reaction is a concerted dimerization. Means within single step we can get a dimer. Within single step we will get a dimer. Irradiated with suitable lambda of carbonyl compound, excited state is pi 2 pi star triplet, and it is single step dimer. Means one will be excited state, other will be ground state. So during dimerization, one molecule is excited state, another at ground state. So one will be excited, other will be ground state. One unsaturated partner at excited state, other will be at ground state. Okay, so here, especially in this case, they liberate variable products. So you'll expect mixture of products. First one head to head, and one more is head to tail interaction. Head to head, head to tail. Here head to head is in presence of polar solvent. If I use polar solvent, you will get this, and if I use non-polar solvent, you will get this one. Reaction product depends on solvent. Head to head interaction, head to tail interaction. Okay, so what about stereochemistry? Now stereochemistry of product is always it is cis trans cis fission. Always cis trans cis fission is going to be expected. Cis trans cis fission is expected in this one. Okay, and especially this reaction is, it is a triplet sensitized reaction. Okay, triplet sensitized reaction. So there is a requirement of benzophenone. Triplet sensitizer is required. Benzophenone, acetophenone, and even xanthone. Any one of this triplet sensitizer is required. Xanthone, acetophenone, benzophenone is required. So without this, it is impossible to generate triplet state. Triplet state is what? Pi 2 pi star triplet only. It is a triplet sensitized reaction, but not n2 pi star. It is only pi 2 pi star. Now only rings we are applying. Dimerization possible with only rings. Open chain dimerization not possible. Okay. So here this is the reaction generally. This is a double bond. Here how many equivalents I am using now? 2 equivalents. So this will be taken as 2 equivalents. So here you may get this product. This is double bond. And here see, this is hydrogen thick line. Here thick line. And here it is dotted line. And here it is dotted line. So here how many units they will give? They will give 2 photochemically. Now this is called head to head. So this is called head, and below part is tail. Now this is called head to head interaction. Now one more is there, head to tail. Head to tail nothing but carbonyl will undergo 2 pi cycloaddition. Now here this is the tail. See, here stereochemistry remains same. Now this is cis stereochemistry, and here it is a cis stereochemistry. See this. Hydrogen hydrogen same side, cis. Hydrogen hydrogen same side, cis. But what about here? Trans. And here also trans. That's why cis trans cis fission. Cis trans cis fission. This is a key point. And what about here? It is also cis, and here trans cis fission. But things here, this is head and this is head. Head and head both are opposite side. 2 heads are opposite side means head and tail interaction. This is head and tail. So out of these two, which is major, which is minor, depends on solvent. Suppose see, if I take solvent as methanol, is it a polar or non-polar? Polar. So now this is found to be major. Due to chelation it is found to be major. Suppose if I take benzene, this is major. Non-polar. Non-polar solvent, if you take CCl4, benzene, toluene, xylene like that, on the time this is major. Suppose if you take any polar solvent, so there is a chelation establishes between this with respect to solvent. On that time this is major, this is minor. So it is a dimer. See, I am taking only cyclic rings. Photocyclodimerization not possible for open chain unsaturated carbonyl. Open chain unsaturated it is not possible. Clear? Right. Here see they will give like this triplet sensitized. On the time they won't mention these compounds. These compounds they won't mention. So they will give simply triplet sensitized. Now two products here. This is called head, this is tail. Head, tail. See, head is here, tail is here. Now head is here, tail is here. Now these two molecules, two heads are above. Two heads are above. Two heads are above. But here head is above, head is below. That is called head and tail interaction. So if I take any carbonyl and see this is unsaturated part. So this part is taken as head and this part is taken as tail. This part I am saying. It is any membered ring. You can take either 5 membered, 6 membered or 7 membered irrespective of the size. If any double bond present in ring, outside carbonyl is present, this is called head, this is tail. Head and head. Head and head means both heads are same side. Yet this is head, it is also head. Now this is taken as, this is head and this is taken as tail. Below part is tail, above part is head. So this is called head-head interaction, here head and tail interaction. So this is major in polar solvent. This is major in non-polar solvent. So every time write down trans product, cis fission. So here this is cis, two hydrogens are same side, cis. Now two hydrogens are same side, it is also cis. For this molecule I am saying, second molecule. Now when these two combine together, what is this? Cyclobutane derivative. This cyclobutane derivative having cis and see between these two trans and here cis. So this is a molecule, photochemical C6H6. What is the answer? Here I am writing pH. Photochemical methanol. What is the answer? So all are triplet sensitized reaction. Even if I not write triplet sensitized, you write down as triplet sensitized. Triplet sensitized, methanol is the solvent. So photochemical, same product. Double bond and C, photochemical methanol, here double bond and here double bond. See, they won't give two equivalents, we need to take two equivalents. That is the difference in reaction. Two equivalents they won't mention. You have to take two equivalents of this reaction. Write dimer every time. Identifying photodimerization is not easy. Photocyclodimerization. I am going to write only major, minor you write down. See, what is major in this one? See, these two are dimer together. This is head. Is it tail is major? Now this is tail is major. What is the stereochemist over here? Is it trans or not? This is cis, here trans, cis fission. And if you write two heads same side, that is minor. What about here? Is it two heads are major or not? So you can write like this, C double bond. This is thick line and here also thick line pH. This is H and this is pH. This is called head to head interaction. This is head to tail interaction. Minor I am not writing, minor you write down. First is major, second is minor. So will you write this? Which is major? Head to head interaction is major. Here solvent is methanol. Head to head interaction is major. You work out this. Here also remains same. Alpha comma beta is here. Here head to head interaction is major and here also head to head. Take this two molecule two times. Take 2 units. 2 units and here 2 units. You will get the answer. Okay. So see these two carbon substitutions we are dimerizing. This carbon hydrogen, this carbon methyl should be on same side. Take this molecule 2 times. Okay. This carbon hydrogen, this carbon methyl same side like this. See. Here phenyl hydrogen are orienting one direction. So I am writing hydrogen phenyl same side like that. Clear? Open chain never undergo photodimerization. Photodimerization is not possible for open chain. Be careful. If any alpha comma beta open chain is given, photodimerization is not possible. This molecule if I give photochemically methanol or ethanol, anyone if it is given, remember no photodimerization. Photodimerization is not possible. This is not exist. Don't go for dimer of this one. Don't write 2 double bonds at one side. Don't write a clear answer for this one. This molecule never undergo photocyclodimerization. Ignore this. So depends on solvent, your answer changes for photodimerization reaction. Next, second one. Photocyclodation. photocycloaddition. Next concept after photodimerization, next is photocycloaddition. Difference between dimerization and cycloaddition is, in dimerization, two molecules of one type we are going to take. In cycloaddition means one is this molecule, second one is a different partner other than this. Means a simple olefin, simple triple bond is going to be taken as a second partner. See, wherever I use the word cycloaddition, they should not be same. Dimer means one molecule double. One molecule double is called dimer. One molecule combined with new molecule, that is called cycloaddition. So that's why in dimerization they will mention only one molecule. By using this slide you need to make them into double. Take same molecule two times. That is called dimerization. Suppose if you go for, this is one molecule, a normal olefin is taken. That is called cycloaddition. Means one ring is responsible to give by combination of two unsaturated partner, that is called photocycloaddition. Photocycloaddition means ring is going to be added to unsaturated molecule, that is called photocycloaddition. Almost all dimerization reaction, cycloaddition reactions are same, but dimerization takes place only with one molecule, but cycloaddition takes place between two different. One will be alpha comma beta unsaturated, second one will be definitely unsaturated partner. Unsaturated partner means it might be a olefin or it might be a triple bond. Okay, here I am not using a separate olefin. I am using a only one molecule identical two times I am using. Is this molecule undergo dimerization? No. This molecule never undergo photodimerization. You remember this. I will explain why in photochemistry of olefin. In photochemistry of olefin I will explain this molecule. Why this not undergo photocyclodimerization. Next is photochemistry of olefin only. So there you will understand clearly why this kind of molecules are not involving in photocyclodimerization. First you write reactants as well as possible. First you complete left side. Don't wait for answers. Okay, if you wait for answers, it will be disappears out. So this is already homework. These three are homework for you. So that's why first you write down the reactions. Answer you leave later. Now see, what is photocycloaddition? See, the addition reaction between cyclic alpha comma beta unsaturated carbonyl compound and olefin or alkyne in light is called photocycloaddition. Photocycloaddition is the addition reaction takes place between cyclic conjugate carbonyl and simple olefin or triple bond, that is called photocycloaddition. Okay, see, reaction product is here cyclobutane derivative similar to dimerization. So, but the cyclobutane derivative formed by two different molecules, but where cyclobutane formation takes place by one molecule, that is the difference. Okay. So here direct I am writing irradiate with lambda of carbonyl compound, okay, Then what about reaction excited state? In this reaction excited state is different. N2 pi star triplet. N2 pi 2 pi star triplet in case of dimerization. This point asked in GATE exam. What is the reaction excited state of photodimerization and photocycloration? Photocyclodimerization pi 2 pi star triplet. Triplet sensitizer is required. But here N2 pi star triplet. Now, what about intermediates? Intermediates are 1,4 biradicals. Intermediates are 1,4 biradicals, similar to PB, pattern-Buch reaction. Intermediates are 1,4 biradical. Now, always reaction proceed with stable 1,4 biradical. It should proceed with a stable 1,4 biradical. It should be stable. Reaction product is cyclobutane derivative, irradiated with lambda of carbonyl compound. Excited state is N2 pi star triplet excited state. Intermediates are 1,4 biradical. So here I am taking excited state carbonyl compound forms a charge transfer complex. It will forms a charge transfer complex with ground state olefin. So that is known as Exiplex. So where you learn this word? Exiplex word. Where you learn? PB reaction. In pattern Buch also we learn Exiplex. Here also you will get Exiplex. What is Exiplex? A charge transfer complex formed between excited molecule and ground state molecule. First I am taking carbonyl compound, it is excited by absorbing light. This will combine with a ground state molecule. Now these two are forming a charge transfer complex, that is called Exiplex. This Exiplex slowly gives 1,4 biradical. Clear? So especially this one, highly nucleophilic olefinic carbon, carbon initially bonded to carbonyl alpha carbon. So this statement you understand later. You remember, highly nucleophilic olefinic carbon should be combined with or bonded to carbonyl alpha carbon. Highly nucleophilic olefinic carbon. Olefin, how many carbons are there? 2. Suppose if the 2 carbons are not same, one should be more nucleophilic, other should be less nucleophilic. Whichever is more nucleophilic, that should be initially forms a first bond with which one? Carbonyl alpha carbon. So what is carbonyl alpha carbon? This is a statement which I am giving. See, this is alpha comma beta. Carbonyl alpha beta. Now I am taking a olefin which is unsymmetric. Is it symmetric or unsymmetric? Unsymmetric. This carbon having 2 hydrogens, this carbon having 2 methyl. So between these two, which is more nucleophilic? Above carbon or below? Above is more nucleophilic. This is more nucleophilic carbon, not this one. So if this carbon is more nucleophilic, initially forms a first bond with this one. So here you will expect a first bond with this. Later on you will get a biradical. You will get a biradical like this, 1,4 biradical. Highly nucleophilic olefinic carbon initially forms a first bond with which one? Alpha carbon. See, is it alpha carbon or not? Okay, this is alpha with respect to carbonyl. Once if alpha carbon bonded to this highly nucleophilic carbon, okay, then there is a formation of 1, 2, 3, 4. You will get a stable 1, 4 biradical. Out of 2 olefinic carbons, you try to identify which is more nucleophilic. That will combine with which one? Alpha carbon, first one. Then later on beta carbon. So final answer is this one, C. When these 2 radicals are combined together, you will get a 4-membered ring like this. So here this is the answer. So what is intermediate in this one? 1, 4 biradical. So now this is at which state? Photochemically. This is at excited state or not? It is at excited state. N2 pi star triplet I am using. Means here I am using a triplet sensitizer. Some molecule itself it is converts N2 pi star triplet. Some molecules may not. On that time I can use triplet sensitizer. So these reactions are belongs to triplet sensitized reactions. This is excited, this will combine with this and forms a hexaplex. That hexaplex will give this one. Without formation of hexaplex, it is impossible to generate biradical. So now we can proceed a reaction such a way that it will give stable biradical. Always reaction proceed with a stable 1, 4 biradical. Then excited state carbonyl combined with a ground state olefin forms a charge transfer complex. Okay, how I written in PB here also same. So don't participate carbonyl, you participate carbonyl conjugate double bond. In normal PB reaction, carbonyl and double bond will combine. But right now, double bond and double bond will combine in hexaplex formation. This is photochemically excited. So it is a charge transfer hexaplex like this. If you write carbonyl double bond to this one, carbonyl double bond to this one, what is that? PB reaction. This never participate. When double bond is under conjugation, this never participate. Only this will participate. If you participate this one, that is called PB. On that time they won't give double bond. Conjugate carbonyls they won't give. That's why in Pattern-Buch reaction they won't give conjugated double bonds. If 5-membered ring involved in reaction that will produce cis fission products. So this point you need to remember, it is important for CSR. See here, which membered ring? 5-membered or not? If 5-membered ring involved in photocyclo addition, on that time see here you will get always cis fission. This is called fission. When double bond of carbonyl and simple olefin combine together, there is a fission product is expected. Fission means attached product. After attachment, this is called fission junction. This particular junction carry cis stereochemistry if 5-membered is involving. If photocyclo addition, if 6-membered is involved, you will get trans fission. If I am participating 6-membered ring involved in reaction, that will produce trans fission product. Trans fission is measured. Trans fission is measured in case of 6 membered. Cis fission is measured in case of 5 membered. This you need to remember. Experimental evidence is there, that is a big history. So you remember these 2 points, that you will understand clearly in photochemistry of olefins. So here you will get methyl, and see this hydrogen is above the plane and this is below the plane. That is the answer. What is the fission? Trans fission. But what about fission here? Cis fission. See, which is more nucleophilic out of these two? This is more nucleophilic, it is less nucleophilic. It is nucleophilic and this is electrophile. Nucleophile always combine with alpha carbon, remember. Whichever double bonded carbon having more nucleophilicity, that will combine with alpha. Then these two will give this bond. Highly nucleophilic double bond combined with this alpha carbon. That is major. Here one more product is expected, that is minor, you can ignore it. Here I am writing this. See, here I am writing cis, this is minor. This is major and this is minor. Always trans is major in 6 membered. Cis is major in 5 membered. You need to identify which is more nucleophilic, which is less nucleophilic. If you understand that point, this concept is over. OME. Photochemical, what is the answer? Like this they will give. It is very important for part C. Remember, photocyclo addition is important for part C. You should know which carbon attaches to alpha carbon. Photochemically, normally in this nucleophile attaches to beta carbon thermally, but photochemically which carbon? Alpha. That's why this question they are asking. Kinetically control normal reactions, highly nucleophilic carbon attaches to which one? Beta. It is alpha beta. You know Michael addition? Michael addition nothing but adding any nucleophile on beta carbon is called Michael addition. But right now where we are adding? Alpha. This is photochemical reaction. Photochemical reaction quite opposite to thermal reactions. Now you need to identify which is more nucleophilic out of these two. Which is more nucleophilic? Above or below? Above is more nucleophilic as compared to below. Because mesomeric effect. See, if it is migrated, this carbon is more nucleophilic. Mesomeric effect. And here also mesomeric effect. If any lone pair conjugate to pi electron, that is called mesomeric effect. Now this is more nucleophilic. Wherever I am writing negative charge, that negative charge will attaches to alpha. Negative always attaches to alpha only. I given clear charge. Then write the answer. Write stereochemistry even. Fission stereochemistry is most important. So this is given even in Neff reaction. Neff reaction, they follows this. I will show in reagents this one. Right. See in this one, more nucleophilic carbon attaches to alpha, write down 5-membered ring, and this will be attached here. Here OMe, OMa, right? Then later on this inner carbon attaches to beta. And see, here it is a 5-membered ring, cis stereochemistry is expected. You can write 2 dotted line or 2 thick line. And in this one, same way, this attach here, this attach here. Write down what is stereochemistry? Trans. Here you write down 2 hydrogens in trans manner. And see which is more nucleophilic here. So this is positive and this is negative. This is more nucleophilic. This carbon is a high nucleophilic carbon. This will attach here. And this will attaches here. So I can write like this. Here cyano, C double bond O. Here hydrogen and methyl both having same stereochemistry like this. Whichever is more nucleophilic, that carbon should attaches to alpha carbon. Okay, this is more nucleophilic. And here, this is positive and this is negative. So this will attack here. Same way you need to write. But what is the ring size? Every time try to see the ring size. Here this is nitro, hydrogen, and here dotted line phenyl. See trans, there you will expect. Only this concept is very important for photocycloaddition. They will give 5-membered. 5-membered means cis. 6-membered means trans junction. And see the olefin, what kind of olefin it is. Either electron rich olefin or electron deficient. So if any donor is present, this carbon will attach on alpha. If withdrawing group is present, below carbon will attaches to this one. So I will write 2 dots, there you need to attach here. So this is more nucleophilic, it is attaches this one. Right? Now this is more nucleophilic, it is attaches to this one. So these two are remain same, you combine these two. And here you may expect this kind of photocycloaddition. Here this is the answer. sp carbon is more nucleophilic. See, what is this carbon hybridization? What is this? sp. What about this carbon hybridization? sp2. sp. So if you migrate electron, more electronegative element bearing negative charge is more stable. That's why this negative charge will attack here. Is it alpha carbon? Which is alpha in between these two? Below is alpha, this is beta. This carbon will attach here, this carbon will attach here, because this I can write positive charge, here I can write negative. More electronegative carbon will attach here. sp is more electronegative as compared to sp2. So if you write negative charge on sp, it is very close to nuclear, then that negative and nucleus will be get attracted together, so this is found to be stable. Don't forget to write stereochemistry. Stereochemistry is very important for this. Photocycloaddition, this kind of reactions are important. See, you migrate here, attack here. I will show reagent question also with related to this. So be careful. Photocycloaddition not easy to identify. Major problem is unable to identify this. They will ask part C question in middle of the step. 3 to 4 interconversions are there. In 3 to 4 interconversions, one of the step is photocycloaddition, followed by they will ask any name reaction. Then any reagent question. Like that 3 to 4 interconversions are possible. This is negative and this is partial positive. So will you work out this? Directly this bond will migrate here and this will attack here. Write down this answer. Now this will migrate and this will attack here. Two different double bonds. It is one pi partner, it is one more pi partner. Two different will combine together. So write down cis stereochemistry here. Now here also remains same. It is alpha comma beta unsaturated carbonyl. Even ester also possible. So this two will combine and this two will combine. Ring junction is 5-membered. 5-membered cis, 5-membered cis. Other groups are unaffected. This reaction is very important for alpha comma beta unsaturated carbonyl. Even carbon-carbon triple bond can participate in reaction photochemically. Only one thing you need to remember, stereochemistry for photochemistry. Maximum cases you will get cis stereochemistry. Any photochemistry, if any question comes regarding photochemistry, if you are confusing, because photochemically supra is preferred. Suppose if it is antra, opposite stereochemistry. So 2 pi supra every time. Is it possible to combine? 2 pi, 2 pi. Now here also same. This will combine with this. This is C double bond, this double bond is unaffected. Now here you may get this. This is more nucleophilic. More nucleophilic joins here. This will join here. You rotate this molecule and attach here. Simple. Right? Will you do this? So this is intramolecular reaction. This is called intramolecular photocycloaddition. Intramolecular photocycloaddition. So here this carbon will attaches to this one. That is the answer. Intramolecular photocycloaddition between alpha comma beta unsaturated and simple olefin. That the olefin is away from ring. This is CSR question. Camphor, carbon to camphor we can prepare. So how to write the product? Write down the 6-membered ring. Now you write down these two. You two join together now. So here this methyl is above the plane. These two are joined together. Now this having a methyl. Now here middle how many carbons are there? 1, 2, 3. So here you write down dotted line. 1, 2, 3. 1, 2, 3. Here what is ring size? 6-membered or not? When 6-membered is given, what is the stereochemistry? Trans. Intramolecular PB, intramolecular photocycloaddition, these two are confusing parts. Be careful. See, if they want to ask photocycloaddition, here they will give double bond. Double bond is conjugate to carbonyl. Suppose if they want to ask pattern opposite reaction, this double bond they won't give. If double bond is not given, this double bond combine with carbonyl. That is called PB. PB, double bond and carbonyl both are very close to each other. That's why you see intramolecular PB and intramolecular photocycloaddition. These all are intramolecular photocycloaddition. Now, even here we can write the answer C double bond. Now I can write a 5-membered ring. This 5-membered ring joined together. So here I am writing OAC. So here outside how many carbons are present? 2 carbons. Here 1, 2. That is the answer. Carbon camphor. This is called carbon camphor. This is called carbon. Carbon on photochemical irradiation, that will give carbon camphor. Carbon camphor. This carbon combined with this one. This carbon combined with this This carbon combined with this. Here don't apply high nucleophilic carbon. Don't apply high nucleophilic carbon attaches to alpha carbon because strain is a concept. Intramolecular strain is a concept, not nucleophilic carbon. Open chain always highly nucleophilic carbon attaches to alpha carbon of carbonyl. But in this one always answer depends on strain. Whichever direction you are getting a strain free product, that direction it is predominate. Here don't apply highly nucleophilic carbon attaches to alpha. That answer will not get. Okay. So your answer is always depends on molecule attaining stability without crowding, steric strain. That's why carbon camphor is more stable. This is called carbon camphor. So I think you observed this somewhere else. Where you observe this? Nourish 2, type 2C. Nourish type 2, this I given. And that too, in that case also that is exception. So like this I given, see in your notes it is there. Suppose first I given like this. If I give photochemical, so if I give photochemical methanol, what is your answer? Camphor, if I give this one, what is your answer? Carbene intermediate. But if this molecule is given, I not given carbene intermediate, I say ketene. Ketene, then alcohol will attack on this carbon and here I will add hydrogen. I explain, this carry tricycle. Tricycle exception is there, carbene formation not takes place. Reason also given. So this is prepared by using which method? Preparation of this carbon camphor done by using photocycloaddition. And what is the starting material used for this one? Carbon. So from here to here, what is the answer? Photocyclodimerization. And from here onwards, if they given this second, photochemical methanol, this is called Nourish 2. Nourish 1 followed by transfer of hydrogen. If carbonyl is very closer to gamma hydrogen, that is called Nourish 2. Right now it is Nourish 1, photochemical methanol. So here you may expect a Nourish 1 product. So from here to here it is A, from here to here it is B. Refer your notes, already explained. Here I broken, this hydrogen I added here I written O-Me. Yesterday I written, see in your notes. This interconversion is most important. From here to here A, from A to B is already explained Nourish 1 product. It is given in CS, sir. So this I am writing clearly for your understanding point of view. See, this and this same reactions. This carbon you can also write like this. This molecule you can also write like this. See, outside this double bond is there or not? This double bond I written like this. Sometimes they will give like this, carbon camphor. Both are same, that and these reactions both are same, they are not different. So these two are get combined together. So here it is 1, 2. Now these two combine together. It is a carbonyl double bond, simple double bond. These two combine together. So this carbon combined with this carbon combined with this, that is the answer. Alpha comma beta unsaturated. So this is a double bond. Photochemically your answer is A. This is on treatment with methanol, your answer is B. So what is AB in this reaction? This is CSR question. Intramolecular photocycloadation is most important. So what about photochemical? Photochemical 2 pi plus 2 pi cycloadation. These two will be added. This bond attaches here and this carbon attaches here. So this is your answer A. Then followed by methanol. If you add methanol, this will be attached over here and this bond will migrate and this will transfer out. So after transferring keto-enol tautomerism, direct step I am applying now. So here I can write OMe. Now here you will get double bond OH. Can I? This alcohol after attacking here, this sigma bond is going to be broken and converts into 5 membered. 4 membered, 3 membered become 5 membered. Strain is reduced. And this double bond migrate this side, you will get carbonyl compound, enol form. Enol form on tautomerism. This is on tautomerism. Finally, here you may expect C double bond